one of humanity's first attempts at rocketry is the ancient Chinese legend of Wan Hu, who tried to fire himself to space on this wooden rocking chair loaded with rockets, and not much got left behind from him except this equation, which was found in the manuscripts to describe his height as a function of time. Now, the problem before us right here is to figure out during what time Wan Hu reached outer space. Okay, so he estimated he would be in outer space at 11,587 feet. And this is the equation. So we want to say, basically, according to that equation, when is he 11,587 feet up in the air? In other words, h equals 11,587. Okay? Now, this is what we're going to solve right here. And we're going to use the quadratic formula to do that. So let's figure it out. First, I'm going to write the equation that we have, negative 16t squared plus 870.4 times t equals 11,587. And if you prefer x, that's fine. Go ahead, switch to x. But I'm going to change this equation around so it looks a little bit more like something we would be used to factoring. Okay, I'm going to subtract the 11,587 from each side. And now you see it's something we could factor, if only it weren't so gross. For this problem, we're going to use the quadratic formula, not because you can't factor it any other way, but because this is one of those cases where it's actually nicer. So let's think about what I have. A equals negative 16, B equals 870.4, and C equals negative 11,587. And we're just going to plug this into the old quadratic formula that we know and love to get our variable equals, remember what this is, negative b plus or minus the square root of b squared minus 4ac all over 2a. You might remember the song. So go ahead and plug these things in. This becomes negative 870.4 plus or minus the square root of, this is going to be a long one, 870.4 squared minus 4 times a is negative 16, and times c is negative 11,587. Okay, and that entire thing divided by 2 times negative 16. Now, when you do that, you're going to get two numbers. And these two numbers happen because of this plus or minus right here. First, you would do negative 870.4 plus that huge square root. And then you would do negative 870.4 minus the square root. I'm not going to go through all the details. You can do that with the calculator. But here's what you're going to get. T1, one of those square roots, equals approximately 23.24. And T2, the other square root, because of the plus or minus, is going to be 31.16. And the relevance of these comes in if you think about what the picture of this rocket flight is going to be. If I make the old XY axis, where in this case the x-axis is time and the y-axis is height. What we have here, as time marches on, you see height is going to increase, and he's going to reach the top, and then he's going to fall back down to Earth. Okay, so that's what this trajectory is going to look like. And what we're asking is, well, when does he reach space? Or at least Wan Hu's estimation of where space is. Right? It's above a certain altitude. It's going to be between two locations in time. Okay, here they are. There's T1, there's T2. So how do we say in between two locations in time? In other words, what I'm trying to say is this part of the timeline right here. Well, we have interval notation for this. This just becomes 23.24 in the case I'm looking at, all the way to 31.16. Okay, and this would be your answer right there. Now that's one task. The second task in this problem is to rewrite Wan Hu's equation of motion in vertex form. See, vertex form is very useful because that gives you the maximum altitude. So let's go ahead and do that. Let me get the original equation again. This is going to be negative 16t squared. You know, it is a bit of a pain in the neck equation. Negative 16t squared. But real life examples like shooting yourself to space in a rocking chair are seldom easy. right? There's going to be some ugly numbers involved, not to mention carnage. So, let's see, minus 11,587. Oh, no, that's not it. This is just the equation right here. So now what I have to do is remember, not B, H. Is this H? Oh, this is going to get confusing. Here, let me just rewrite this equation. There, that's my equation. I'm going to say H, in other words, the horizontal shift, the x location of the vertex, is equal to negative B over 2A. You're familiar with this, I hope. Now, B is 847.4. So here, let's plug some things in. H equals negative B, 870.4, divided by 2A. And A is negative 16. Okay, so when you plug this in, well, we're going to get something like 27.2, I believe. So that's H. And now what we need to do is find K this way. We're going to plug K into that equation, okay, where I'm plugging 27.2 back into my function, the height equation, which unfortunately has the same variable H. Please don't get confused there. But we're just going to plug it back in like so. Negative 16 times 27.2 squared. And then, let's see, plus 870.4 times 27.2. 27.2, see if I can squeeze that in there. Okay? Now, you're going to want to use more decimals, right? I rounded 27.2, but you're going to want to use all the decimals. And what you're going to get in this example that I'm doing is something like 11,837.44, right? If you really want to go crazy with some decimals, you can follow along with the numbers if you want to repeat this. But basically what this means is that right there is, this is the maximum height. Okay, this is the K value. If you remember what H and K are, again, I'm sorry, H is the same variable here, but H and K represent the vertex of this parabola. That's the maximum height. H tells you how much time has elapsed. K tells you how high he's gone. So we know here the time that he reached the maximum height itself, and we can write this in vertex form like so. I'm going to say H of t, his height, equals negative 16, that's the A right there, times t minus h. Remember, this is the location of the vertex now, don't get confused. 27.2 squared plus 11,837.44. Okay, if you're having trouble seeing where those numbers fit in, just think about this as something you might be more familiar with. The vertex form looks like the following: A times x minus h squared plus k. That's what I've got right here. Okay, and that's how we do all aspects of this parabola application.